Now, if you haven't been asked to do this in the past, you're going to be asked to do this now. You have to memorize these four patterns. So they were discovered basically by grabbing all sorts of different acids with bases, and they always got the same thing. They're all neutralization reactions. They all release heat. And so they're the patterns we discovered, and you have to use those patterns to be able to do these examples down here. So if you get like an acid, you have to know which acid. If I give you something, you have to recognize it's an acid, and then if you get something, you have to recognize, oh, that's a metallic oxide, or that's a metal, or that's a base, or it's a carbonate. You have to know which one it is, which one of these four it is, and so basically how to do your ionic compounds and the states. Okay, now there's a video there which is quite useful. Hopefully you get time maybe to do it in class, probably not, to be honest. And so you can test for neutralization, sort of doing like a crude titration. You can test for hydrogen gas, pop test, and lime water test for the carbon dioxide gas. And then we're just going to do a little bit more from that. So you also need to know how to write ionic equations. Now, when you get to redox, another way to know it's a spectator is the oxidation numbers stay the same, but we haven't learnt that yet. The key thing to know is when you have something written as aqueous, that's just a convenience to write this formula unit. What's actually happening is there's just these ions floating around, but you can see that's quite messy. And so we write equations like this. All right. And so if you see something aqueous at the start and aqueous at the end, you know that the nitrate ions were floating around at the start and the nitrate ions are floating around at the end. And so these things didn't change. They were floating around before and after. So you get rid of them. And this is an actual insoluble product that's actually got some ionic bonds to it and is actually formed, and it's not just floating around like it was before and after. And so the things that were floating around are now locked in place, and so that's the only thing that actually occurred. And so that's what is an ionic equation. It's just the ions going into something. And so that's written balanced states, ionic charges, all done. Okay, so that's how you do ionic equations. This is an acid-base example. Now, again, just be aware that that is really just none of this, except for this. This is actually formed into a covalent compound. These are just floating around. So sodium was floating around before and sodium's floating around afterwards. So get rid of them if you're doing an actual ionic equation. And so that's the way to write it. If you wish, you can write it as a hydronium ion. These are interchangeable. But then to balance it, you got to make sure you add two waters.